Assalamualaikum warahmatullahi wabarakatuh, and salam sejahtera to all my students and all students out there. In this video, we are talking about the redox reaction subtopic called displacement of halogen from its halide solution. So in this video, we are focusing on element in group 17: fluorine, chlorine, bromine and iodine. The reaction is actually similar to metal displacement, but now we have to look at the reactivity of element in group 17 in order to understand this reaction. So let's start with the concept first, and then I'll discuss on the reaction. Okay, let's start. Displacement, a reaction of halogen from its halide solution, is a reaction that involves group 17 elements. So you have to recognize these two terms, halogen and halide or halide solution. Okay, the statement says that the atom of halogen elements has the tendency to receive electron to form halide ion. So why? I will draw you the electron arrangement of fluorine atom to explain about the tendency of the halogen element to receive electron. The statement says here that the halogen will undergo reduction reaction and act as oxidizing agent. So from previous lesson, we already learned that reduction reaction is gain of electron. So you have to remember reduction is gain of electron. Okay, the reactant or the element that undergo reduction reaction is the oxidizing agent. So if the reactant or the element undergo oxidation, so oxidation is loss of electron, so the reactant will become the reducing agent. So in this case, halogen is the oxidizing agent. So let's look at the electron arrangement of fluorine atom first. So fluorine atom, the electron arrangement is 2.7. The atom have 7 valence electron. So this is according to the total number of proton. So total number of proton is equal to total number of electron. So this is fluorine atom. The electron arrangement is 2.7. So as you can see, fluorine atom here haven't achieved a stable octet electron arrangement. So what the atom will do is the atom will share its valence electron with another fluorine atom and form fluorine molecule. So you have another fluorine atom with the same electron arrangement, and it will share its valence electron to form fluorine molecule. So this is from atom, so it will change to molecule, fluorine molecule, because you have 2 atoms now that share the electron, the valence electron. So how many electron that each atom share? They will share 1 electron each, forming a pair of electron. This is called a single covalent bond. Yang ni yang you belajar masa form 4. So the electron arrangement is still 2.7. Okay, sebab dia tak accept electron, dia hanya share saja electron tu. So in this statement, it says that atom halogen has the tendency to receive electron. So masih ada lagi keupayaan untuk terima elektron sebab dia punya electron arrangement masih lagi 2.7. So this molecule can accept electron. So if each atom accept 1 electron, so we need 2 electron to be received by these 2 atoms. Okay, so what it will form is, it will form the fluoride ion. So fluoride ion, the electron arrangement become 2.8. So let me draw you the fluoride ion. So the electron arrangement will become 2, 8. So this is ion. Electron arrangement 2, 8. The ion have 1 negative charge there. So because of we have that 2 atom fluorine, so you should have 2 fluoride ion. So saya letak 2 tu untuk menunjukkan ada 2 lah fluoride ion tu. Or you can also draw another fluoride ion at the back of this first fluoride ion. So it's either one can be accepted. For this reaction, as you can see here, fluorine molecule, we write down the formula as F2. Okay, so fluorine molecule can accept electrons, so we can put the half equation as F2 plus 2E, and it will produce 2F minus. Why minus? Because you already add 2 electron in the molecule. So this is molecule, it turn into ion. So same as chlorine and also bromine. The difference is that the chlorine atom is bigger than the fluorine atom. So why? Why chlorine atom is bigger than fluorine atom? Because chlorine have 3 shells occupied by electrons. So if I draw the arrangement, the electron arrangement of chlorine atom, so you will get Cl. The electron arrangement is 2. And then you have 8. And the third shell, you have 7. So same as fluorine atom just now, the chlorine atom will also share its valence electron with another chlorine atom to form chlorine molecule. So the electron arrangement will be 2, 8 and 7. So same as the first chlorine atom. So this is chlorine molecule. Chlorine molecule. Chlorine molecule can also accept 2 electron to form chloride ion. So the electron arrangement of chloride ion will become 2, and then 8. The third shell will also form 8 electron. Okay, so same as fluoride just now. So we have 2 chloride ion because we have 2 chlorine atom in 1 chlorine molecule. So you have 2 chloride ion. So from Cl2, okay, Cl2 accept 2 electron, form 2 Cl minus. So this is what we call as half equation. So as you can see, both half equation, fluorine and chlorine, can accept electron. When the fluorine atom or chlorine atom accept electron, means fluorine and chlorine will undergo reduction reaction. So the halogen accept electron, form halide. So this is halide. F minus and Cl minus is halide. F2 and Cl2 is halogen. According to these 2 electron arrangement, as you can see, the size of chlorine atom is bigger than fluorine atom. When the size is bigger, so the nuclei attraction for chlorine atom is weaker than fluorine atom. So the ability for chlorine atom to accept electron is lower than fluorine atom. So in this case, fluorine will be more reactive than chlorine. So we will say that fluorine is more reactive. Why fluorine is more reactive? Because fluorine is smaller. So the ability of the atom to attract another electron from another element is higher compared to chlorine atom. So going down the group, as we already know and we already learned during your Form 4, you know that going down the group, the size of the atom increase. Okay, so the size of atom increase. So what happened is that the ability of the nucleus, inside nucleus you have proton and neutron. So the ability of the nucleus or the proton to attract electron from outside of the atom will decrease. So going down the group, we know that the reactivity decrease. What does it mean by reactivity decrease? Okay, the ability for the atom to accept electron decrease, become weaker. So kenapa benda ni ada kaitan dengan the displacement of halogen from its halide solution? So now, let's look at the experiment here. So this is the experiment, the first examples that given to you in your textbook, where we add a chlorine water in potassium bromide solution. So you can see that this is the formula Cl2, and then they use KBr. Why KBr? Because for all reaction that involve sodium, potassium and ammonium ion, so the solution or the salt solution is soluble in water. So potassium will always be positive ion, so potassium bromide is the most suitable solution to use in this reaction. Okay, now let's look at this reaction, chlorine and KBr. So this is a displacement reaction for halogen from its halide solution. So we compare chlorine and bromine. So we can see that chlorine and bromine. Okay, chlorine is higher than bromine in group 17. Going down the group, we say that the reactivity decrease. So chlorine is more reactive than bromine. So what we can say for this reaction is that we have potassium bromide and also chlorine water. So chlorine water is added into potassium bromide solution. You can refer the textbook to look at the procedure. So what we are doing here is that we add chlorine in potassium bromide solution, and the product form is a new product. Okay, so we say that chlorine is more reactive, so chlorine is able to displace. So this molecule will be able to displace bromine from its halide solution. So what happens is that, okay, potassium bromide, okay, will change to potassium chloride, and bromine will be displaced as a molecule. So bromine here will change as molecule. Okay, so as you can see, the chemical equation is not balanced, so you have to have 2 potassium bromide and 2 potassium chloride. So this reaction is called as displacement reaction. Okay, dia displace kan. Chlorine lebih kuat, lebih reaktif, dia akan tolak keluar ion bromida daripada potassium bromide. Okay, jadi inilah yang dimaksudkan dengan displacement reaction, okay, ataupun displacement of halogen from its halide solution. So you have to differentiate between halogen and halide. So this is halogen. Okay, bromine here is also halogen. Okay, potassium bromide is halide solution. And potassium chloride here is also a halide solution. So when we say that we displace bromine, we are displacing the halogen from its halide solution. So we are displacing bromine from potassium bromide solution. So let's look at this reaction in terms of redox reaction. So we start with bromine first because bromine undergo oxidation reaction. So let's look at the half equation. The half equation for bromine will be Br minus. Why Br negative ion? So the negative ion exists in potassium bromide, so Br minus. The bromide ion will release electron to form bromine molecule. It will release 2 electrons. So you need 2 bromide ion. Another thing that students always confuse, how to write the half equation for halide. Do you still remember that during the first part of the video, I explained about how halogen can accept electron to form halide? So for example, if you have chlorine here, chlorine, this is halogen, accept electron to form halide. So halide is the ion that already achieve a stable octet electron arrangement. So if you start the reaction with halide solution, the halide solution will not be able to accept electron again, because halide is actually the ion that have already achieve stable octet electron arrangement. So same as bromide here. So bromide already achieve a stable octet electron arrangement. So bromide ion will never accept electrons. So you cannot write half equation. Let's say you write down Br minus accept electron. So plus sign, okay, means accept electron to form what? So this reaction will not happen. So this is a reaction that will never happen to bromide ion, because bromide ion have already achieved a stable octet electron arrangement. So for bromide, okay, bromide dia mesti akan datang arrow dulu. Dia mesti akan release electron dulu. Okay, because bromide can only release electron. Bromide cannot accept electron anymore, because bromide ion have already achieved stable octet electron arrangement. Remember that. So in this reaction, okay, bromide release 2 electrons. So obviously the reaction is oxidation reaction. If we look at the half equation for bromide ion here, you will see that the bromide ion release electron, or you have loss of electron here. So this is oxidation reaction. Oil oxidation is loss of electron. Okay, if you want to explain it in terms of change in oxidation number, so you'll see that the bromide ion, the oxidation number is -1. So the bromine molecule is 0, because bromine molecule is element. So the oxidation number increase from -1 to 0. So substance that undergo oxidation is a reducing agent. So this is the reducing agent. So for chlorine, so chlorine we start with Cl2, because chlorine water, chlorine molecule exists as Cl2. Chlorine will accept electron because chlorine is more reactive, yang kita bincang sebelum ni. Okay, chlorine is more reactive, so chlorine dia nak terima electron tu and form chloride ion. So 2 chloride ion. So this reaction, okay, chlorine accept electron, gain electron. So you have gain of electron. So this is reduction reaction. Reduction reaction. So if you want to explain in terms of oxidation number, also you can explain. Okay, so the oxidation number for chlorine molecule element equals to 0. Okay, chloride ion, oxidation number -1. So you can say that the oxidation number decrease from 0 to -1. So same reduction reaction. So the substance or the reactant that undergo reduction reaction is the oxidizing agent. So this is the half equation for both reaction. So you can form the ionic equation same as the previous reaction. Okay, so in this reaction, the ionic equation will be, you can see here you have same number of electrons, so you can just cancel out the electron and then you copy again, okay, the reactant. So you will have 2Br minus plus Cl2 produce Br2 minus plus 2Cl minus. So in this reaction, as you can see, the bromide change into bromine, the chlorine change into chloride. What we have to understand in this video is that, okay, which reactant is the strong reducing agent and which reactant is a strong oxidizing agent. So this is the conclusion. Okay, according to your textbook, okay, it says that, okay, when going upward in the halogen series, so as you can see, this is the halogen. Okay, halogen is the oxidizing agent because halogen undergo reduction. Okay, so the strength as oxidizing agent increase, okay, when going upwards in the group 17, and when you go downwards in the group 17 as halide. Halide is the reducing agent because halide undergo oxidation. So the strength of the reducing as a reducing agent will increase when going down the group. So what is the effect? Okay, what is the effect of this conclusion? So when you have a reaction between chlorine, you have chloride, and then you have bromine, and you have bromide ion, and also you can have iodine and iodide ion. So in this reaction, chlorine is more reactive than bromine and iodine. So these two reactions will definitely happen. Chlorine can displace bromine and iodine from its halide solution. So bromine can only displace iodine from its halide solution because bromine is more reactive than iodine. Okay. Okay, thank you for watching this video on displacement reaction. Okay, I'll try to demonstrate to you the reaction of displacement of halogen from its halide solution later. If you have any problems, just comment in the comment area below. Terima kasih watching my video. Thank you.